So what are composite functions? Now, as I said, composite functions are generally a more complex form of functions. Why is that? The composite function is simply a function within a function. How does that work? In order to understand it, I'll give you an example. So if I told you you have two functions, one is called f of x and it is equal to x squared, and your other function is called g of x and it's equal to 2x plus 1. These are two separate functions. They're simple functions. They're okay. They're easy to figure. However, if I want to make a composite function, then I'm putting a function within a function. If I want to state it, I'm going to have, for instance, f of g of x. In other words, this g of x, let's choose blue. In other words, this g of x is going to enter inside our f of x. And in other words, it's going to be f of g of x. And that means our function x squared is going to be our x of x inside x squared is going to be replaced by this function. And you're going to have your 2x plus 1 as your new x, and you're going to square the whole thing, which will leave you with 4x squared plus 4x plus 1. And that would be your new function. This would be your composite function. Now, the kind of questions you get in this, I would, for example, ask you to find f of g of 2. In other words, find the value of the function f of x if f of x if you're replacing the x by g of x, and in that x you're going to have it equal to 2. In other words, you're going to come to each x here and just replace it by 2 because you've already got the general function. So it's going to be 4 by 4, which equals to 16, plus 8, which is equal to 24, plus 1, and that will give you 25. Now, it can work both ways. If I gave you the same exact two function and I told you, yes, your f of x is x squared and your g of x is 2x plus 1, and I want, instead of f of g plus 1, f of g of x, I want g of f of x. Here you're going to be doing the opposite. You are replacing each x inside the g by the entire function f of x. And that would mean your 2x plus 1, you're going to come here and replace your x by x squared, which means g of f of x is equal to 2x squared plus 1. And now if you want to get g of f of 2, your answer is going to be 4 by 4, which is 4 by 2, sorry, which is going to be 8 plus 1, which gives you 9. As you see, g of f of x is not equal to f of g of x, so it does matter the order you put them in. Now, that would, this would mean that after this explanation, you do know what a composite function is, which means it's a function within a function, and you know how to figure out the general formula of a composite function. You put the inner function within the outer function, and you're going to get the general function. Now, what you need to know is you also need to know how to figure the domains of the new function. Now, here, if you want to find the range and the domain of a function, you can simply look at the general function here, but the most important thing is you don't just figure it out. You need to look at the inner function most importantly, and the domain of the inner function is going to be generally the domain of the whole function, the composite function. So, domain will, for example here, the domain is going to equal to x, all the real numbers of x, because simply for this, the domain is all the numbers, and for this, the domain is all the numbers. This is a straight line equation, and this is going to be a parabola. So both of them are infinite. You don't have any restrictions. But if you get a more complex function, then you should think of the restrictions. Let us here take an example. So let's think of a function with restrictions. So let's say our f of x is equal to 1 over x, and let's say our g of x equals to radical x plus 3. Now, first of all, let's get f of g of x. And this is going to be, we're going to put the g of x inside our f of x. So it's going to be 1 over, and our x is turning to our g of x, and it's going to be x plus 3. On the other hand, here we're gonna have g of f of x, where we're gonna put inside our the x over our g the f of x, and it's going to be 1 over x plus 3. Now, I'm not going to ask you to find the number, but I'm going to ask you to find the domain and range. Here the domain is, you know, the numerator should, if there's a radical, it should be greater than or equal to 0, and here that is not a case. In our denominator, we need to make sure it is not equal to 0, and since it's a radical, we also need to know it's not less than 0. So our x plus 3 should actually be greater than or equal to 0. And this would mean that our x is greater than or equal to -3. And this would be our domain. This is domain. Now, if we want to write our range, we need to think of, we're going to have here, our range is going to be every value that you can have here for x. So technically, we know that since there's a 1 on the top, we'll never have a 0, because it's just the reciprocal of a radical. And in this case, our range is going to be all numbers except 0. And here, it's going to be all numbers except 0. Oh, it's actually going to be everything greater than 0. So let us, the way you find the range, it's better to always try to draw the function. So first of all, we know that 1 over x is generally the general formula of 1 of, it might be hard for you to draw it, but if you want to know how the graph would look, it would look something like this. So you want to make sure that first of all, it's always going to be positive, because we said this is always positive, and we know that the radical is always positive, so this is generally always positive. So we know our range is always going to be greater than or equal to 0. But then we also know that it will never equal to 0 because there is a 1 on top. And this would mean that our graph would look somehow like this maybe. Again, I'm not exactly sure of the graph because it has to do whole translations and etc. But in this case, we know that it's going to be positive, and this would mean our range is actually going to be y is greater than 0, and that would be it. Now, if we want to do it for the second part of the second one here, we know that the numerator, there's no denominator, so we're only looking at the numerator, and we know our radical should be greater than 0, but we also know that most importantly, our 1 over x here cannot equal to 0 because the denominator cannot be 0. So first of all, we know that x is not equal to 0. Second of all, we know that 1 over x plus 3 is greater than or equal to 0. In other words, our 1 over x is greater than or equal to -3, and that would mean that 1 is greater than -3x, and our x is going to be less than or equal. Oh, now it's turning because we're dividing by negative. It's going to be greater than or equal to -1 over 3. And that would be how it works. So we know that x is not 0 and is greater than -1 over 3. So x would be, it's actually from -1 over 3 to 0, where 0 is not included, and then we also know it's going to be from 0 to infinity. So this would be our range. Now if we look here, on the functions themselves, we know that g of x is going to be x plus 3 is greater than or equal to 0, which means x is greater than or equal to -3. And for f of x, we know that x is not going to equal to 0. Now here, if you look at the ends, we knew that for f of g of x, x is actually greater than or -3. So what we did is we just looked at the inner function, which is g of x. Here what we did is we know that x is I did a small mistake here, it's actually a big mistake, whatever. So we know that x is going, 1 over x, so x cannot be 0, and we know that 1 over x plus 3 has to be greater than or equal to 0, 1 over x is greater than or equal to -3, and then 1 over is going to be 1 is greater than or equal to -3x, and x is going to be greater than or equal to -1 over 3. So yeah, actually I didn't have a mistake. So what we did here is that we looked at the inner function. Oops, I moved still on the eraser. And we know that our f of x can never be equal to 0. And that was our restriction for the domain. But we had also a new restriction. So always look at the inner function, make sure that the restriction for it is going to be there, and look at the outer function if something gets new. And that would be how you find domains and range for composite functions.